Alright, so I'm going to go back to 6.7, convertible kinetic energy, and I want to look at a very nice problem here, okay? So we have let's see what they call it, a paintball. There's the paintball, and here we have a disc, okay? We have the velocity of the paintball going at 11 meters per second, and the velocity of the disc is 0, okay? So the paintball is a paintball. You know, if the paintball collides with an object, it goes splat, right? So it basically breaks up and all the paint gets stuck on the disc. Okay, so that's the basic idea here. Disc, 0 velocity, paintball, 11 meters per second. The inertia of the disc is 0.075, and the inertia of the paintball is 0.05 kilograms. Okay, and we're looking at this in the Earth reference frame. Okay, we're looking at it in the Earth reference frame. So it says the disc is struck face on by the paintball traveling at this speed. Now, look at these questions A and B. It says, what is the initial relative velocity of the disc and the paintball? B says, what is their reduced inertia? And C says, if all the paint stays on the disc, what percentage of the original kinetic energy is converted to kinetic energy? So as you can see, these are build-up questions. A and B are building up to calculating the convertible kinetic energy. Okay? Remember, we had something that looked like this. The system kinetic energy, and I want to put the E there because it's the kinetic energy of the system in the Earth reference frame is equal to the kinetic energy of the center of mass, which is non-convertible, plus the kinetic energy that is convertible. Okay? So A and B are really questions which don't require much understanding. Of course, you can just go and solve it, okay? But really, as you can see, question C is what are they looking for? Is how much kinetic energy is converted to internal energy. So I want to stay here, okay? I want to look at this in a few different ways. The first thing is just from first principles. Remember that if we look at the system kinetic energy, right, before collision, okay? Let's look at before collision. Let's call that initial. What is that equal to? There's nothing new here. Half m p vp squared plus half md vd squared. That is the kinetic energy before collision. And if you go and calculate this, okay, we've got the inertia, we've got the velocities, we've got everything. This comes to 3.025 joules. Okay? Then if you calculate the system kinetic energy, let's remember it's in the Earth reference frame, final, what is that equal to? Right, we know that it smashes into it, and then these two objects begin to move together. Okay? So it says if all the paint stays on the disc. So that now becomes a totally inelastic collision, right? Totally inelastic collision, which means that the inertias are then added together, half total inertia, v final squared. What is the final velocity of this system now? Okay, how am I going to calculate that final velocity? Remember, we can just use conservation of momentum. M of the paintball, velocity of the paintball, plus m of the disc, velocity of the disc. This is the initial state, is then equal to the total inertia times the velocity final. Okay? So we've got all this information there, velocities, inertias, velocities. We don't have this. If we solve for this, we get 4.4 meters per second. Okay? So if you plug that in, you get 1.21 joules. Okay? So now, what is our delta K? Our delta K is K final minus K initial, which is 1.21 minus 3.025, and you get minus 1.81 joules, which is the negative of your delta E internal. And so if we have a totally inelastic collision, what we're saying is that we have the maximum convertible kinetic energy. Okay? Meaning that all the available convertible kinetic energy was actually converted. That's what we're saying. Okay? So now, what do you think this K convertible needs to be? It has to be the same as this value, which is 1.81 joules. And how do we calculate K convertible? There are two ways. The first way, K convertible, what am I doing? K convertible is half reduced inertia V relative squared. Okay, so what is that? That is inertia of the paintball plus inertia of the paintball times inertia of the disc divided by inertia of the paintball plus inertia of the disc times the relative velocity between the initial relative velocity between the paintball and the disc, which is 0 minus 11 squared. So we're just going to put a 11 squared over there. Okay, so we've got the inertias of all of these, and if you calculate this, you should get 1.81 joules. Okay? What I'm trying to do is I'm trying to show you that when we looked at the original way that we could look at this, we looked at our initial kinetic energy, our final kinetic energy, and because it's totally inelastic, our conclusion is that the maximum amount of energy that could be converted was actually converted into kinetic energy. Okay? And that equaled this 1.81. Then if we went and actually calculated it based on this formula, these two should be the same. And lastly, so I'm going to break this video up into two so that it's not too long. The second way of calculating the convertible energy is to first calculate the system kinetic energy in that inertial reference frame, calculate the non-convertible center of mass kinetic energy, and then solve for this. Okay? I want to write this out quickly because this is going to segue into the next one. So I'm going to rewrite it. So we know that's the one way of calculating our convertible kinetic energy. And the other way that I just wrote is the system kinetic energy is equal to the kinetic energy of the center of mass plus the kinetic energy that is convertible. Now what is this? This was half mPVP squared plus half mdVd squared, okay, which we already calculated here. That's the total amount of kinetic energy in the beginning. And then what is this? This would be half the sum of the inertias times the velocity of the center of mass squared. This is the non-convertible kinetic energy. And then this is the convertible kinetic energy. Now, what was this? Remember, we calculated this to be 3.025. We calculated it above. And this is half the total inertia, right? That's just given. This is 0.05, 0.075. Now, what is the velocity of the center of mass? What is the velocity of the center of mass? right? It is exactly the same as calculating this final velocity, okay? So the velocity of the center of mass, again, is exactly the same as calculating that final velocity, mp vp plus m dvd over the total inertia. Okay, we've got that. We've got the velocity of the paintball, and the velocity of the disk is 0. We calculate this, we should get 4.4 meters per second. Okay, so we've got that v center of mass squared. So I'm just going to rewrite this. This is 1.21 joules plus k center of mass. So we've got 3.025 minus 1.21 is k center of mass, which is 1.81 joules. Do you see the different ways of calculating this? You've got these two ways. You've got the actual formula, and you've got this one, which is kind of more from first principles. I just really suggest that you know how to. So the point is that this is the maximum amount that can be converted. It doesn't necessarily mean it will be converted. It depends on the type of collision, whether it's elastic, totally or completely inelastic, or just an elastic collision. Okay? But we saw in this case that it is a totally or completely inelastic. So all of the kinetic energy that can be converted was converted. Okay, and now it says what percentage of the original kinetic energy is converted to kinetic energy? What percentage? So all you need to do is say this amount that's converted divided by the original amount of kinetic energy, and that is your percentage. 0.6 or 60% of that original kinetic energy was converted into internal energy. Okay? So, in the next video, we'll start to now look at this next question, D, which is to look at this problem, but in a different inertial reference frame. Okay, see you in the next one.